Sorry for the interruption. Had a little issue on the side, but we're just going to pick up this problem where we left off. And where we left off was saying that when we took the derivative and squared it and then added 1, the result after adding 1 was almost the same as the result before adding 1. The only difference was the plus and minus in the middle. And the reason that was beneficial is the trinomial with the minus in the middle factored into this square of a difference, whereas the trinomial with the plus in the middle factors into this square with the sum. And it's not a conventional factoring, but because we got this trinomial from squaring up here, and noticing that the only difference was the sign in the middle, then these formulas basically say that we can refactor this into the same thing it was before, but just with the plus in the middle. So why is that beneficial? Because this expression, 1 plus the square of the derivative, lives under a square root. So I'm about to put a squared something under a square root. That's incredibly beneficial. Therefore, our arc length is the integral from 1 to 2 of the square root of this guy. Y squared plus 1/4 y to the negative 2 squared. Yes, the square will cancel the square root, but you got to be careful when you do that, because when you square root a number, it comes out positive. You have to make sure this guy on the inside is positive. But a squared number is positive. A squared number is positive even if it's reciprocated. Everything under here is positive. So yeah, the expression in parentheses is positive, meaning that when we square root the square, it actually comes out to be the same. And some of you are probably wondering, why did you just say all that? Why didn't you just cancel the square and the square root? Well, to make sure that I make my point completely clear, what's the square root of 3 squared? Well, 3 squared is 9, and the square root of 9 is 3. Well, what's the square root of negative 3 squared? It's not negative 3, because negative 3 squared is positive 9, and the square root of positive 9 is 3. In general, a square root comes out positive when you're treating it like a function. It's only when you square root both sides of a pre-existing equation where you bring in the plus minus. And if you'll notice here, the square and the square root didn't cancel because the thing getting squared wasn't positive. I guess what I'm saying is this: when you square root x squared, it's not always just x. It's x if x is greater than or equal to 0, but it's negative x if x is less than 0. If the thing that got squared was negative, then the square root of its square is the opposite of that. It sounds like a super nitpicky thing, and in a sense it sort of is, but whenever you're canceling squares with a square root, whenever a square root is canceling an existing square, you really have to make sure that the thing getting squared is positive. Otherwise, if it's not positive, then you can't just cancel and get away with it. All right, so overlooking that, this is now easy. The antiderivative of y squared is 1/3 y cubed. The antiderivative of 1/4 y to the negative 2 is negative 1/4 y to the negative 1. Yes. And this is being evaluated from 1 to 2. Let's rewrite this as y cubed over 3 minus 1 over 4y from 1 to 2, which is almost our original function. This problem is clearly designed to work this way. All right, let's see what we get. If we substitute the upper limit, we get 8 over 3 minus 1 over 4 times 2 is 8. And if we substitute the lower limit, we get 1 over 3 minus 1 over 4. Common denominator is going to be 24. Let's put it all together. If I hit this with some 8s to get my 24, 8 times 8 is 64 on top, minus, if I hit this fraction with some 3s to get the 24 on bottom, 1 times 3 is 3. Watch your signs over here. I hit this fraction with 8s to get 24 on the bottom. The top becomes 8 and it's subtracted, so minus 8. And if I hit this fraction with some 6s to get a 24, then I get a 6 on top, but it's minus a negative, so it's positive. And then we just put it all together. Let's see, 64 minus 3 is 61. Minus 8 is 53. Plus 6 is 59. The arc length is 59/24. So as you can tell, these arc length problems get a little bit ugly because we have to go through a lot to set up the integrand. But the answer on this one wasn't too bad, not compared to the previous example.